Name is okay. So today's theme for our webinar are digital challenges, and we had quite a start with it. So in this series, this is the last webinar in this series of about the documentation of images, and today we will talk about the digital challenges about three-dimensional objects and other digital objects which are more and more entering in the storages in the collections of museums of our museums, and museums are facing the new challenges regarding the large-sized materials, storage solutions, long-term archiving, and others. So today we have two speakers, Diane Zorich from the Smithsonian Institution, who is Director of Digitization Program Office, and Frank von Hagel, who is Research Assistant from Institute for Museum Research SPK in Germany. And okay, we have lost a couple of minutes, so I will no longer speak about the challenges and give the floor to Frank, and he can start with his presentation.
Yeah. Hello, everybody. I will now try to start and share my presentation. The hardest part of this. Yep. So if you can tell me, can you see everything? Okay.
Yeah, we can see it.
Okay, great. So today we are in the third webinar of this series, and we would like to talk about 3D, augmented reality, virtual reality, and artificial intelligence. These kinds are encountering more and more frequently by us and in the museums. So what can we do with it? What should we do with it? This webinar will address a few of these digital challenges, mainly 3D. And the question now is, are there solutions for the needs of museums, or can existing industry standards for easily adapted and we can use them? So 3D digitization, is it getting easier? In the last years, we saw an increasing number of 3D models, or somebody told it, digital twins. And I don't know if I like this term. I'm still thinking about it. And also museums have created many 3D objects in a constantly growing number. At the moment, we have a variety of different processes for this digitization and qualities that are available for creating 3D. And we now can look into the objects. We can make burnt papyrus rolls visible available. There's a fantastic project called Vesuvius Challenge. And we can bring historical sites back to life using augmented reality and virtual reality. So many things that can be done, and we even can digitize a large number of objects in a series within a short period of time and create the 3D models at the same time. By the way, the collects of the archaeology and natural history museums and collections are very innovative in this. So the fact is, hardware and software were becoming increasingly cheaper. They have contributed significantly to this, and from high resolution process to 3D models, they could be created by mobile phones and tablets. Everything seems to be possible. So I think about it, the new process seems to offer endless possibilities, new ways to make objects tangible in the digital space, new ways to educate and impart knowledge in digital space, new ways to research large amounts of objects information in order to recognize connections and context, regardless of location. So, but what is the right way? Are these simple models even suitable for the use in museums? So, unfortunately, many questions remains unanswered, or existing solutions are not really suitable for the requirements of use in museums. As we have already seen in the previous webinars, cultural institutions, museums, also libraries and archives, have very different requirements than industrial companies. For example, due to their mandate to preserve and communicate the data for a long time. Not least because of this, despite the sharp fall in prices for hardware and software, high costs arise in the long-term preservation, the saving of data to make data accessible, and the complexity of the data. The digital objects are linked to many relations with other digital analog information in analog works and knowledge. So it requires a high level of data competence and clear guidelines with regards to tools and standards, even as we spoken about linked data and the images preservation. It seems that some problems come up again, even much bigger. So how can we use these new digital copies for documentation, for research, for presentation? And how can we identify them for, even if the number of digital twins grows up and up? So, and the long-term costs, I don't know how we can reduce these costs. I'm quite sure that step by step it will be cheaper, but it's not the real solution. We have, oh, I'm confused. I missed the navigation. Okay. So the tools, the standards has to be saved. We have to say and to development. We have to show how can we manage the paradata of the digital objects, which document, how can we document the technical environment we made the digital twins. And so we have still a lot of questions, and there are certainly still many unanswered questions, but perhaps it has become clear how many questions there are and where we can start working in the museums. In the first step, there's certainly a lack of suitable infrastructure in the institutions. And we think about the usability of our data and the right standards to make these informations and digital objects more accessible and usable in this area. And and also we have to show how the existing standards has to develop for the use cases in a museum. Maybe CIDOC can try to help develop these existing standards for the museum use. But on the other hand, that shouldn't stop us from starting these tasks. And one institution, which is already very far along this path, will now present its work. So I would now like to hand over to Diane Zorich. Diane is the director of the Smithsonian Institute, the Digitization Program Officer. And the Smithsonian Institute does fantastic work in the area of collecting digitization, 3D digitization, digitization assessment, and they are also using the latest news technologies for digitization, but also for the communication. And I'm very excited to learn more about it. So please, Diane.
Thank you. I am going to share my screen. Give me 1 second to do that. Okay. So do you just see my slides?
We can see them.
Great. Thank you. Thank you, Frank, for such a nice introduction and also for framing the questions so well. There are a lot of questions, and I'll bring some of the ones that are specific to our journey. And that's what I'm going to talk about today, is our journey at the Smithsonian in starting from 3D digitization to building a full-fledged 3D program. Let me give you a little bit of information first about the Smithsonian, because we have challenges that most museums don't have. We are the world's largest museum research and educational complex. And we have 21 museums and 8 research centers. And we have researchers doing research over 100 countries around the world. And of our 21 museums and 8 research centers, they collectively hold 157 million objects and specimens. So we have a scale problem is what we call it. We have a lot of things. My office, the Digitization Program Office, actually has 3 programs: policy and analysis, which does the assessments of digitization across the institution. What's been digitized? What more do we want to digitize? That kind of thing. The Collections Digitization Program, which is responsible for traditional 2D digitization, as well as record creation and enrichment. And then I was asked to talk about our 3D program, so I'm going to focus on that from here on in. Just to make sure we're all on the same page, 3D digitization is the process of scanning an object to collect the 3-dimensional data about its shape and its appearance. And then that data is used to construct a digital 3D model. So we started experimenting with 3D digitization in 2012 to better get an understanding of the technology and also the possible use cases with our audiences. We now, today in 2024, have over 3,000 3D scans of objects, ranging in size from a small coin to things as large as a space shuttle. So the challenges for us of 3D digitization are many, but for us, we also need to try to scale it up and sustain our digitization efforts. So we kind of look at the challenges from a high-level view in these 4 broad areas. The first one is scanning itself. There's a lot of tools on the market to do this. As Frank mentioned, you can now even do it with your phones, your mobile phones. Each of the tools are designed to focus on some aspect of data capture, but the process is still labor intensive insofar as you need a human being to do it, to do the capture. But once you do scan an item, you then need to process that scan into a high resolution digital model. And there's various software to do this. But you can't really use the high resolution digital model for every application. First of all, your systems would probably grind to a halt, and many platforms just can't handle high resolution files at this scale. So you really also have to create what we call derivative models. They basically use the high resolution scan and create downscale and recompile the information in a way that's conducive to the platform you want to use them on. For example, if you want a low-res version for the web, then you would create a derivative model of that low-res version. If you want a version for 3D printing, you would create a derivative model for that as well. And then finally, you have to deliver these models somewhere. You want to share them, right? So you want them online using 3D viewers or in an augmented reality or virtual reality environment. So over the last few years, as our 3D models have grown, our team has been working on developing what we call a pipeline, kind of a workflow that will address some of these challenges through automation, and therefore allow us to scale up and do even more 3D digitization at one go, to do entire collections instead of just one-offs here and there. So from here on in, I'm going to talk about our process using this model. This is actually two models, but they were kind of posed together. These are 3D scans of a Tyrannosaurus rex attacking a Triceratops. We 3D captured both fossil specimens from our Natural History Museum, 3D digitizing every single bone. And the scans were actually used here by our exhibit designers to experiment with how they wanted to place the fossils themselves in a new hall that they were developing. And this is the final pose, if you will, that they decided upon having the T-Rex attack the Triceratops. Now, in our ideal world of 3D, what we would like to do is have this capture event. You still have to 3D capture the data. Oops, sorry, my screen is jumping on me. Then you would get the data and you would want to create that high resolution model and you want to deliver it, in this case on the web, let's say. And we would love to be able to do that with the push of a button. But really the reality is more like this. You capture the data and then you ingest it, and you have to do all sorts of work with software programs to create the high resolution model and those derivatives I mentioned. And doing this work in the middle is highly resource intensive. You have to have a human in the loop, right? Who knows these programs, who knows how to work with the data in these programs. And in fact, my 3D team tells me for every hour of capture, of 3D capture, they wind up spending at least 5 hours of processing in this middle area. Okay, so the first thing we thought in thinking of our workflow is if we could automate this middle bit, that would be huge for us. It would be such a time-saving device. So in fact, that's what we did. Our 3D team created a software processing program that they call the Cook, and they call it the Cook because basically it delivers recipes. They call, the derivatives are considered recipes of one sort or another. So the Cook processing software, which by the way is open source and available on GitHub, you're welcome to use it, automates the creation of the derivatives I told you about. And basically what it does is it takes that whole host of software I showed you on the previous slide, and it automates that. So if you ask for a file for 3D printing, the Cook will generate that file for you, right? So we don't have to have the human in this part of the loop as much, and it saves us a tremendous amount of time. But there's other parts of the workflow that are also time consuming. So what you see on this slide is kind of a high level view of our 3D workflow. We call it the 3D pipeline. And it starts with the capture event, which it always will. You have to capture the data. And we hope to end it with presenting it online. And for us, we do that largely through a 3D viewer we've created called Voyager, which is how we deliver our models on the web, basically. But everything in the middle box here is really resource intensive. And this is where it's ripe for automation for us. So what we do is we 3D scan, we capture the data set. I mentioned we have over 3,000 models now. It becomes increasingly onerous to manage those data sets at that level. So we needed another tool that was a management asset system. If you work with 2D imagery, I'm sure you're familiar with DAMS, digital asset management systems. Our asset management system, which we call PACRAT, is akin to a DAMS, except that it's much more robust and it accommodates the more complicated data sets that you find when you generate 3D data. So we have this tool PACRAT, which is our asset management and preservation tool, and Cook, which I mentioned earlier, which is our data processing tool, and they communicate back and forth. And then we deliver the files through our viewer called Voyager. But one of the great things about Voyager is we wanted to do more than a traditional 3D viewer, which basically spins the object around and lets you zoom in or out. We, and I'm sure you do as well, have a lot of information on your objects that you want to present to your users present a richer user experience. So what we have done is we created a authoring tool for the Voyager viewer called Voyager Authoring, which allows the experts at the Smithsonian, so that's the educators, the curators, the researchers, to add content to the 3D model to create a richer experience. Voyager also has AR, augmented reality functionality, so users can display the model in their local environment through their mobile phones, and I'll show you all of that in a second. It's really easier for me to show you a demo of Voyager than to describe it. So I've got a little quick video I'll walk you through. Let's start that up. So here's what the page you get when you go into our 3D viewer for that same model. Here, the curator added the catalog record for the T-Rex. It looks just like any other catalog record with its fields. But he also added an article he wrote for the audience. T-Rex is, of course, an animal that fascinates many people. So he addressed the portions of the T-Rex that are fascinating, the teeth, the long bones, the weight, where it's found, etc. He also annotated the model, putting the names of some bones onto it. And you can click on those annotations and find out more information. So that's what he did using Voyager authoring tool. But the Voyager data viewer comes with its own set of tools, one of which is you can embed the viewer in any website. So we give you the embed code, we give you the share codes for social media. We created a lot of tools that allow you to look at the model in different modalities. So you might want to change the light source. You might want to change the material composition. In this demo, we are actually doing measurements. You can pin points and the viewer will calculate the measurement. And since 3D models at their core are data, the measurements are very accurate. So that's all innate in the Voyager viewer. This is also where you would find those derivative files I told you about if you wanted to download this model for another platform. These are the derivatives we have for download, as well as the metadata, which you can download separately from the actual model if you want. So this is just kind of a quick view of our viewer. We also have a little labs page at the top here. You can see where we're doing some experimental work with accessibility, trying to make the viewer more accessible to those who have visual impairments. So then I also mentioned that Voyager has AR-enabled all of our models. So if you use Voyager on your mobile phone and you will click on a corner button that says AR and you click on it and you hold the phone up to an area in your local environment and the model appears in that environment as an augmented reality model. And we decided to do this for a number of reasons. One, it's fun, it's interactive, it's engaging for our audiences, but it also gives you a sense of the object's scale that is hard to achieve on a screen. It's hard to achieve in any way unless you go to the exhibit. But we also realize that many people will never visit our exhibits. So this will give them an example or a way to get a sense of the scale. If you put the woolly mammoth, which you see here on your right, in your office, you will get a true sense of the size of that beast that you cannot get from a screen. So that's another reason we do it. And finally, it's becoming increasingly popular among our audiences because it's prevalent in a lot of social media platforms. I believe TikTok, Instagram, Snapchat all have AR-enabled utilities that allow you to do fun things with AR models. So what's next for us? We have automated a couple of things in our pipeline and we're still testing them, but nothing tests a project as much as a real world example. So we recently had an opportunity to conduct that real world example in our Natural History Museum in the Paleobiology collection, which has millions, tens of millions of fossil specimens. But among the fossil specimens they have that are very valuable are a type of specimen called a holotype. If you're not familiar with that, a holotype is essentially a specimen that's designated as the reference specimen for a species. So if a scientist finds a fossil out in the field, they're not sure what species it is, but they have an inkling of what it might be, they will look at the holotype for the species they suspect it might be and use that to make a determination. So what that means for us in our collection is these holotypes are extremely valuable for scientific research. that also means they're used quite frequently. And when things are used frequently, they suffer from wear and tear. So this made a terrific use case for us, because if we could 3D scan these holotypes, we would reduce the amount of actual physical use on them, and also be able to distribute this information in 3D models to scientists around the world, so they wouldn't have to come to us to look at it. They could do it from their desktop. So although the paleobiology has thousands of these holotypes, we decided to work with the subset for this project of 300. And we set them up and digitized and captured them in a kind of pipeline fashion. The files went directly from capture through that pipeline I told you about, through the Cook, through PackRat, delivered out to the web. And when we were done with that, we went back and looked at the statistics of, how did we do? And we averaged about 10 specimens a day, which is huge for us. And more impressive, I think, is that we were able to go from capture to online delivery in 32 hours in the automated pipeline, which is unheard of for us. Even more phenomenal, I think, is that 84% of the specimens went through that automated pipeline, the Cook in particular, with a no touch, which means no human had to go in and intervene. There was no problem with the derivative files. The Cook did exactly what we asked of that for 84% of the specimens, which is huge in our first test case. So we are going to continue to do these kind of real world test cases here around the Smithsonian, because we rely on them to iterate and to innovate, both the Cook and PackRat, our asset management system, and other things that we hope to automate in the future, with the ultimate goal of driving our success rate even higher. And this will allow us to 3D scan entire collections at one go. So I'm going to end here because I think I've went over my 15 minutes, but I do want to shout out to my terrific 3D team. Ideally, someone from that team would have been doing this presentation, but most of them are at a conference at the moment, so you've got me instead. I'm happy to answer any questions, but if they are of a very technical nature, I will likely refer you to one of the members of our 3D team. So thank you very much, and I'll stop my sharing right now. Okay.
Thank you. Great. It sounds really good. A nearly perfect process.
Not perfect, but more impressive than we could have hoped for a first time run through, right?
And you are publishing the models only on your platform and in Voyager?
Voyager, yeah, Voyager is our platform that we use for publishing on our websites.
Every time the same question comes up, and are you also using other platforms, for example, Sketchfab?
Sketchfab is, no, the reason we developed our own viewer, I'll be honest with you, is early days we used a proprietary viewer, and the company supporting it pulled back, and we got stuck really badly. And we decided we were never going to find ourselves in that position again. We can't. We are the only U.S. museum complex that is partially funded by the federal government. Okay, so it's very rare in the U.S. So to not have our models available is just not, we can't do that. So we decided to build our own viewer, and it's open source. We have a development team that is continuing to add more features and functionality to it. Anybody can use it, and many people are. The Library of Congress here is now using it. There are a couple of institutions in the Netherlands who are using it. Those are the ones I know about. I'm sure there's others. But Sketchfab is one of those viewers that is very popular, but it's also privately owned. And so we have to be careful as a public institution of putting our, as we say, putting our eggs in that private basket.
I understood it. We are in the same situation. On the other hand, should we go with our digital objects to the place where the people are, or should the people come to us?
Well, we also do have partnerships with other platforms where we know certain audiences go. For example, with our natural history collections, we'll be doing a partnership with Morphosource, which is a huge 3D platform for natural history specimens. Okay, so that's where people go to search fossils around the world that are 3D scanned. So we'll be putting ours there as well. Similarly, for education, we've been putting them on education sites that use 3D models in the classrooms here in the US. So yes, we do put them on other platforms, but our first delivery is out to our own platform, right? And then we work on getting it to specific audiences and the platforms that they use. So Sketchfab, you know, we probably, I don't want to speak for my 3D team, but we feel our viewer is better. And so we're going to keep using it. And, you know, you could download our models, you know, people can come and take them. So, yeah. Some of our many of our models are open source. All of those that you will see online follow our terms of use, which are basically you can use it for anything for personal use or educational use.
Thank you, Diane. Thank you, Frank. It was very impressive to see, Diane, the work the Smithsonian Institute is doing. And does anybody have any questions to our speakers? No? Okay, I have one question. As an employee of a museum who has not come to the stage of digitization, 3D and so on, how do we handle with the developing of the technologies? I had the question, you in Smithsonian, Diane, you said that you started this project in 2012, and the technologies are developing, I think, every day, and it is getting better and bigger. Had you had the situation when you had to switch from one tool to another to give a better image for the museum and for the viewers and for everyone?
Yeah, we use that's a great question. We use different capture technologies depending what the use case is, right? This is where the Smithsonian is different from other museums in that we don't generally buy our hardware, we loan it. We get it on loans from companies. And so we get often some of the state-of-the-art technology that's being produced by companies, state-of-the-art laser scanners, for example, who ask us to use them and test them out in real-world situations. So it's kind of a partnership. We get to use these high-end tools, and in return, we tell them what we think of those tools, you know, of how well they work. And I will say one thing all museums have in their favor is versus commercial entities, we have the most complicated information, the most complicated collections, right? If you look at commercial entities like Amazon, which also does 3D scanning, when you order something from an Amazon website and you pull it up and you see a 3D scan of it, right? They do not have as complicated of materials to have to scan as we do, even though they have a broader range of materials. So a lot of the scanning companies, in fact, want to test with our materials because they are so different and unique and complicated and complex, and with the understanding that if it works with our materials, it should be okay in the commercial environment as well. I don't believe you're going to get them to loan materials to a small museum. Obviously, this is where our scale works in our favor, right? We have 157 million objects and an amazing 3D team that the commercial industry already knows about. So we are fortunate enough, we are very privileged in that respect to have commercial entities partner with us in this area. But what you can do as a smaller museum or a singular museum, as Frank mentioned, this kind of capability is already enabled on your phone, your mobile phone. You can use one type of 3D capture called photogrammetry, which is basically photographs, right? 2D photographs, but many of them that get stitched together in software to create a 3D model. And you can do that now on your mobile phone. Any recent mobile phone is enabled for that. So I would say start there, right? And experiment with what you get.
I have a question. I can. I don't find the hand, so I'm sorry. I'm very curious about, well, I found your presentation and Frank's amazing and very, very interesting about all the problems that you can find with digitalizing, no? But one of them that it's always of my interest is the human everyday process, no? You talked about having a learning process and experimenting in 2012, and 12 years from then you have a big production, no, not 1 million, but 3,000.
3,000 is a lot.
It's a big number. Yeah,
Yeah.
totally super big number. So I was wondering, in 12 years, what are some of the lessons learned about how to build a team, how to document the process, how to keep the talent, how to survive over time, no?
Yeah, those are excellent questions. And those were learning curves for us, right? We started with 2 people in an exhibits department who were experimenting with 3D for exhibits, right, in 2012. And then at that time, we had a chief information officer who was very forward thinking, and she kind of saw the potential in other areas of museums. So she brought those 2 people over and gave them a certain amount of free rein to 3D scan a selection of iconic objects from around the Smithsonian. I believe there was about 24 in total. And the goal was to make sure we learned a lot about not only the capture equipment, but how it worked with different types of objects, shiny objects, big objects, tiny objects, objects that were very complicated, objects that might move, like costumes, right? If you have a costume mounted, even the most subtle movement is going to mess up your 3D scan. So things like that. And so they 3D scanned these iconic objects, what they learned from them. Back then, they used a viewer. They put them online using a proprietary viewer that I mentioned that no longer exists. And when that viewer kind of was being sunsetted, we were given, I think, a year's notice, is when we realized we were in on this. This was no longer experimental. We were committed to this. So we had to think about what's the next step, right, going on, and got some funding to hire more individuals, got some funding from a commercial partner to help develop our 3D viewer. Okay, so because that was, you have to hire some very professional people, developers, to do that kind of work and to maintain it. We now have, though, even today, our 3D team, I think, is 6 people total. And that includes 2 developers, and then the rest are 3D specialists and the manager of the program. So it's kind of grown over time. Your question about how do we get talent, I find this really fascinating. When I came here, Hollywood and the entertainment industry was way ahead in this area, and that was another place we learned from. So I had assumed when I came here that that's where they drew their talent. But no, most of the places we draw our talent are fine arts schools. If you look at the people who've been through our program or are with us right now, many of them have Masters of Fine Arts degrees. And in many ways, I now think that makes a lot of sense. There's a lot of creativity, a lot of maker mentality, when you go through a fine arts program. And it was just a natural progression, for example, to go from, working with sculpture and physical sculpture to creating something in 3D, right, and creating a model. And then we have also homegrown our talent. We have hired some people at, introductory levels, and they have become better and better and better and have gone through the ranks. And now I hope they never leave us because they are such experts. So we have been fortunate in not having a lot of turnover either. So that's really great. But I also want to just say that, so you don't have to come from like a very technical industry background. I would say you have to be agile and learning new skill sets and creative and open to that. Most of the people did not come from the museum background. Listen to that. Yeah.
Thank you, Diane. Frank,
Yeah, Frank.
Yeah. One question, your 3D models, are they related to the documentation, the normal documentation of the objects as a digital asset, so they can work inside the house with the documentation and the models, getting the measurements, for example, and so on from the models? And
Yeah,
even you have not to take the original dinosaur.
right. This was a lesson learned, Frank, actually, early on. We do not connect the data and the content with the model. We did it first, and that became real problematic. So that's why we can deliver the model to you, we can deliver the metadata to you, we can deliver it both to you, but in terms of how they're stored and cared for, they're stored separately, right? They're cared for separately. Because they both have different needs and they change, and storing them together was not the way to go, but that's how we started.
So you're handling the 3D data, or the data of the 3D model as an object in your documentation?
It's in PackRat. That PackRat
Mhm.
system
Yeah.
is our data preservation and asset management system, and
Yeah.
all the raw data files are stored and managed there.
Okay. And which kind of, sorry, David, which do you have a list or information which kind of data you are preserving from the
That's one of those technical questions I'll link you
Yeah.
up to one of my team with.
Maybe you can just put it into the website
Yeah.
in the presentation.
I don't want to give out his name because I think he'll be bombarded. I'd rather just give it to
Maybe
you.
it's somewhere on your website and I didn't find
Yeah,
it.
you could actually, you could contact any of the people on our website team. They will be able to answer that question. I cannot.
thank you. David, you heard the question? Please.
Thank you. I have another small question regarding your staff, Diane. Despite being part of the commercial sector, at least by now, I have to agree with the need for independency on particular vendor, as you said. I am curious, how large is your development team? How many people work on the development directly?
Two developers.
Two. Yeah.
And but you know, the remaining team also is very involved in not in developing the code, but certainly in testing it and developing the requirements, features, and stuff like that. But there's two developers.
Thank you.
Mm-hmm.
Okay, thank you. We have a question in the chat. I will read it.
Okay.
Cesar has asked the implementation of virtual models of the collections that allow their interaction with the museum remotely. Has it represented any reduction with the in-person visit to the museum, or has it represented a complement?
I'd have to say the latter for sure. It's complementary to it. People visit the museum and then they go back and look at the model on the website and play around with it, or they find the model on the website, play around with it, and if they get a chance to come to the museum, they make sure to go see the real thing. So it's definitely complementary.
It's good to hear, because some of the museum workers, they are afraid that if they put any images or data online, that after that people will not visit the museum. And it's good to hear that it works in reverse, actually.
Yeah, it's not been our experience for sure.
Marianne, I think even the other direction is correct. The people want to get informed before they come into the collection. And you can catch the people with the digital objects and not on the other way. And maybe we should start to count our digital visitors also, like we are counting our physical visitors.
Yeah. I mean, we do that. We know, even though we're based in Washington, D.C., and Washington, D.C. is a big tourist city in the U.S., we know we're never going to get the worldwide audiences, right? And so for some audiences, this is the only way they will ever interact with our collections. So that's another thing to consider as well. How broad do you want your interaction? You know, if you really want to do great outreach. This is one way to do that.
Thank you. Trilce?
Hi, so thank you, Diane, for the wonderful presentation, to hear a little bit on your process. I'll just say on that last comment on the digital visitors, my PhD student just finished a thesis in which he showed that exactly visitors who cannot join the museum love to be able to access collections. And also he's noticed that there used to be a difference between when you live in a city, you have access to everything, whereas when you live in the middle of nowhere, you have access to nothing. Now in the digital world, this is equal. And so the younger generations have equal access to heritage. This is beautiful. So, but my question was, as you present your process, and I'm looking at the time, but I still wanted to ask the question on the lessons learned. Is there part of your process you wished you had documented that in the past you didn't, and that now maybe you're more aware of?
Yeah, that's a great question. And I can't actually tell you that because I wasn't here in 2012. So I don't know if the team has regrets in that front. I do know they are arduous about documentation now, just arduous. They will not hire a contractor or anybody on the team unless they have proven ability at documenting their work. So yeah, it's very important now. So perhaps that's born of earlier mistakes. I don't know, but I could find that out. One thing I did want to build on what you said, Trilce, is, and the reason we have AR enabled everything, is one of the things we've learned is even in some of the most remote and poorest areas of the world, people still have mobile phones. So they can still access our collection that way. And that was one of the pushes for why we wanted to AR enable everything, because people could still experience our collection that way internationally. And that's the only other technology that's really that ubiquitous across the world in different socioeconomic groups. So until that changes, I don't see us putting it in VR, for example, which is a very niche. We do put it in VR for certain things, but it's not something we're going to invest a lot in for the entire collection because it's just too niche at this point. Yeah. I don't know if you have time, Frank.
Yeah. So you said you have 175 million objects?
157 million.
Okay.
Don't give me any more than I have.
Talk to the archaeologists, I will give you more.
No.
And you have 3,000 done. So how do you select?
Good question. I don't think we're going to ever do them all. I mean, honestly, many of our collections, we don't even have 2D imagery on, right? And it's a question of how do we select. And I mentioned at the beginning, our policy and analysis program, that program is responsible for querying all the museums as to what their priorities are for digitization. And they have to do that every 3 years. And those reports come to us in the Digitization Program Office, as well as around elsewhere around the Smithsonian. But we use those reports to identify projects that we can take on. And there's a number of criteria. It's not just, is it their priority, but do they have the staff, you know, and the time and their personal bandwidth to help us do this, right? Because we can't, they have to let us into their collections. They have to give us space. You know, it's not just us coming in, coming out. It's a collaboration with museum staff members in the particular museums. So there's a lot we also prioritize open access materials over everything. We do not want to 3D scan things that cannot be shared.
Yeah.
Yeah.
It's a waste of time.
Yeah, it is. It's so resource intensive as it is. Why would we put our resources into doing that when we can't get any return on visitor investment, so to speak?
Exactly. Thank you. Thank to both of our speakers. We are running out of the time, but I think we can speak about this along. Lana, she has something to say.
Yeah, I will just for this webinar final thank you. I would like to say just really sincere gratitude to CIDOC, to Trilce, to Mariam on behalf of ICOM Georgia for this really successful collaboration during the 3 webinars of the series, and I'm really sure that we will continue as we started really successfully in 2017 with a wonderful collaboration, and we have really good plans, as Trilce knows, about some structures. And I really thank you, Mariam, for everything you are doing for CIDOC, for ICOM Georgia, and I am sure that we will have another successful collaborative projects next time. Thank you very much. Thank you all the speakers, because it was really wonderful. Unfortunately, today I missed the big part of the webinar, but I'm quite sure that we will get afterwards the deliverables of this webinar. Thank you very much, Rilse, personally to you and all the speakers, and thank you, CIDOC. Wish you good luck, and we will stay in touch.
Thank you. Thank you for inviting me. Appreciate it.
Thank you very much. And just was checking with Edurne who will say it, but so we have already a next seminar series in the planning, already with dates. We also have another series, not yet with dates, and I'm really happy to announce that Mariam will be our official coordinator for CIDOC on this webinar. So this is wonderful. Thank you very much, Mariam, for taking this task, and again, for enabling this collaboration with ICOM Georgia. This is wonderful. Also, I'd like to say, or maybe Edu, you wanna? Okay, so we are recording these presentations, and we will make the 3 of them available as a series once we edit and to make sure that there are a CIDOC series, let's say, and you will receive a link to this presentation. It will be on our CIDOC YouTube channel. This is where we are currently putting all our presentations. And so on that note, again, thank you, ICOM Georgia. Thank you, our speakers. Thank you, Diane, for taking the time also during the holiday season to join us and to share some of your very special process. And as you say, Smithsonian is not like any other museum, but this is wonderful that we were able to hear from an extraordinary location with an extraordinary process. So thank you very much for sharing, and you all for joining the series. So I look forward. Mariam, do you want to close? Thank you.
I just wanted to thank everybody, ICOM Georgia, Trilce, CIDOC, because this was a simple idea which was born on our conference last year, and I am so happy to see that it grows and it gives good ideas and we can share our experience. Thank you. Thank you.
Bye-bye.